Imagine a country where the sun rises a full 2 hours earlier in the east than it does in the west, yet everyone's watch, from the tea gardens of Assam to the salt flats of Gujarat, reads the exact same time.
It's a mind-bending thought, isn't it?
It is. And imagine a landmass so geographically significant that it defines an entire ocean. I mean, the only ocean on the whole planet named for a single country.
Exactly. We aren't just talking about, a political entity on a map here.
Not at all. We are talking about a geological distinctness that stands apart from the rest of Asia, a subcontinent that is, quite literally, crashing into a continent. Welcome, everyone, to a very special deep dive. This is a full summary for UPSC focused by the Simplified UPSC by PPP YouTube channel. I'm your host, and today we are getting into the absolute bedrock of Indian geography.
We're going to strip away the noise and look at the map like a strategist.
That's the plan. Now, before we start charting coordinates and unpacking tectonic plates, I have a very humble request for all you dedicated learners out there. Please just take a second to subscribe to the Simplified UPSC by PPP YouTube channel.
It genuinely helps us a lot.
It really does. And if you're capable and you find value in what we do, if these deep dives help you connect the dots, please think about supporting us on Patreon. Your support is what allows our team to keep bringing this super useful, high-quality content to you.
And on that note, we have to give a massive shout out to all our current supporters and patrons.
Absolutely. You guys are the wind in our sails, and we appreciate you more than you know. Thank you for making this possible. And to everyone listening, don't forget to hit that like button and share your valuable comments. We read them, we love them, and they really help us grow.
We really do read all of them.
Okay, one last resource alert before we begin. Free notes with practice past year questions. PYQs are available right now on our public Telegram channel.
But if you want the premium experience, you'll want to check out the private library.
That's right. I'm talking access to all videos in the series at once, plus organized premium notes, which include detailed notes, extra PYQs, and model mains answers. It's a total game changer for serious prep.
It is. Just DM us on the public Telegram channel to get access.
Okay, housekeeping aside, let's get to the mission. Today, we are unpacking NCERT Class 9 Geography, Chapter 1, India's Size and Location. And joining me to navigate this vast terrain is our resident expert. Welcome back.
It's an absolute pleasure to be here. I was thinking about this on the way in. People often dismiss these Class 9 NCERTs as basic, right?
Oh, absolutely. I read that in school.
Exactly. Oh, I know where India is. But this first chapter, it's so deceptive. It looks like a list of dry numbers and coordinates, but it's actually the foundation of, India's geopolitical destiny.
Geopolitical destiny. Okay, that sounds a lot heavier than just memorizing latitude and longitude for a multiple choice test.
It is heavier. I mean, this isn't just about memorizing that India starts at 8 degrees north of the equator. It's about understanding why India matters in the world.
So it's the so what question.
It's all about the so what. We need to look at India's strategic weight in the Indian Ocean, its relationship with its neighbors, and how these static facts on a page translate into dynamic UPSC mains questions. If you don't get the location, you can't get the foreign policy, the climate, or the economy. It all starts here.
I love that framework. Moving from static facts to dynamic answers. So let's start with the absolute basics then. The grid. Where on Earth are we, literally?
Okay, let's zoom out. Imagine the globe. First things first. India lies entirely in the northern hemisphere.
Okay, that's the first big box to check. We are north of the equator. Simple enough.
Simple enough. But to be precise, we need to look at the latitudinal and longitudinal extent. This basically defines the box that India sits in on the world map.
All right, let's unpack those numbers. I've got the data here from the text, and for our listeners, visualizing this is key. The mainland extends between latitudes 8 degrees 4 minutes north and 37 degrees 6 minutes north.
Right.
And the longitudes are 68 degrees 7 minutes east and 97 degrees 25 minutes east.
Perfect. Those are the magic numbers. 8 degrees 4 minutes north, that's the southern tip of the mainland Kanyakumari, or Cape Comorin as it used to be called.
Right.
And 37 degrees 6 minutes north is the northernmost point up in Kashmir, often referred to as Indira Kul. But here's where it gets interesting structurally. If you just look at those numbers, 8 to 77 and 68 to 97, just do the math in your head. What's the difference?
Okay, let me do a quick calculation here. 37 minus 8 is roughly 29, and 97 minus 68 is also roughly 29. So the difference in both latitude and longitude is about 30 degrees.
Exactly. It's almost a perfect box in terms of degrees. The latitudinal and longitudinal extent is about 30 degrees for both. But, and here's the visual trick that trips people up, if you look at the map of India, the north-south distance looks way longer than the east-west distance.
It really does. India looks tall and sort of narrow at the bottom. Why is that? Is it just a projection error on the map or something?
It's not an error at all, it's geometry. It's the shape of the Earth. Think about lines of latitude, the horizontal lines on the globe.
Okay, the ones that go side to side.
They're parallel lines, they never meet. So the distance between 8 degrees north and 9 degrees north is pretty much the same as the distance between 36 and 37.
Got it. Like rungs on a ladder. They're all the same width.
Exactly.
Yeah.
But lines of longitude, the vertical lines, they aren't parallel. They're widest at the equator, and they converge. They all meet at the poles.
Ah, right. Like the segments of an orange. They all touch at the top and bottom.
Precisely. So as you go north from the equator, the actual physical distance in kilometers between any two lines of longitude starts to shrink. And since India is in the northern hemisphere, our width in kilometers gets compressed compared to our height, even though the degree count is the same.
So that's why.
That's why the north-south extent is about 3,214 kilometers, while the east-west extent is only 2,933 kilometers.
That's a nearly 300-kilometer difference purely because of the curvature of the Earth. That's fascinating. It explains so much about why the map just looks the way it does.
It does.
But sticking to the grid, there's one invisible line that is arguably more important than even the boundaries, the Tropic of Cancer.
Yes. 23 degrees 30 minutes north. This is the game changer. The Tropic of Cancer divides the country into almost two equal parts. And this isn't just, a line on a map. It is a fundamental climatic border. It changes how we live.
How so? I mean, apart from it being a classic quiz question about which states it cuts through.
Well, let's answer the quiz question first because it helps us visualize the path. Imagine you're driving a car from west to east, right along this line.
Okay.
You start in Gujarat, you'd pass through a tiny sliver of Rajasthan, go right through the heart of Madhya Pradesh, clip Chhattisgarh, then cross Jharkhand and West Bengal.
And then into the northeast.
Right. You'd hit the northeast in Tripura and finally Mizoram.
Okay, let me repeat that just to lock it in for myself and everyone listening. Gujarat, Rajasthan, MP, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. 8 states.
Correct. Now, why does that matter? Everything south of this line is technically in the tropical zone.
Okay, tropicalism, what does that actually mean?
It means the sun can be directly overhead at noon at least once a year. It implies a certain kind of heat, specific crop cycles like rice, tropical biodiversity, that kind of thing. But everything north of it, states like Punjab, Haryana, UP, is in the subtropical zone.
Subtropical meaning they have actual proper winters.
Exactly. They have distinct seasons. They have what we call extreme temperatures, very hot summers, very cold winters. This one line dictates our agriculture. It's why wheat thrives in Punjab, but not so much in Kerala. It dictates our seasons, our biodiversity, everything.
So when we talk about India being a tropical country, we are technically only about half right.
Climatically, the whole country is often considered tropical because the Himalayas act as a massive wall, blocking the cold winds from Central Asia. So that gives the whole subcontinent a tropical feel compared to other places at the same latitude. But structurally, geographically, we are a hybrid, half tropical, half subtropical.
That's a great distinction. Now, while we're on the topic of where, we have to talk about how big. Size matters in geopolitics, right?
Absolutely. Territory is power. The landmass of India is 3.28 million square kilometers.
3.28 million. That sounds huge.
It is huge, but context is key here. It accounts for about 2.4% of the world's total geographical area. Now just pause on that number for a second. 2.4%. It sounds kind of small, doesn't it?
It does. It sounds like a tiny sliver when you think of the whole globe.
Right. But here's the kicker, and this is a point you can use in any essay about population or resources. We have 2.4% of the world's land.
But we're supporting what? Nearly 18% of the world's population?
Exactly. We're supporting nearly 18% of the world's population on that little slice of land. And we hold about 4% of the world's freshwater resources.
That is a staggering ratio. The pressure on the land, on the resources, must be absolutely immense.
It is the defining challenge of Indian administration. High population density isn't just a statistic. It's a direct result of this geographical mismatch. We're cramming a fifth of humanity into 2.4% of the space.
And in terms of global ranking, where do we sit on the list of biggest countries?
India is the 7th largest country in the world by area.
Okay, I'm going to put you on the spot again. No peeking. Can you name the top 6?
I certainly hope so.
Right.
It's a standard hierarchy. Russia's number 1 by a massive, massive margin. It spans 11 time zones.
11. Wow.
Then you have Canada, the USA, China, Brazil, and Australia.
And then comes us. Russia, Canada, USA, China, Brazil, Australia. Got it. And India at number 7.
But notice something interesting about that list. Brazil and Australia are huge, but they have vast uninhabitable areas. The Amazon rainforest or the outback desert.
True.
India is unique because a massive percentage of our 3.28 million square kilometers is arable, it's habitable land. We utilize our space much more intensely than perhaps any other large nation on that list.
That's a great nuance. It's not just about the size, it's about the usable size. Okay, talking about boundaries, because size is defined by its limits. We have a massive footprint.
We do. The land boundary is approximately 15,200 kilometers.
15,000.
That's the fence line, so to speak, winding through high mountains, deserts, plains, and swamps. But for a maritime nation like India, the coastline is equally, if not more, critical.
And that number is?
The total length of the coastline, and this is important, it includes the islands of Andaman and Nicobar and Lakshadweep, is 7,516.6 kilometers.
7,500 kilometers of coast? That's a lot of beach.
It is. And that number, 7,516 kilometers, that's the key to our blue economy potential. It's why we have a Navy that needs to be a blue water, ocean-going force. It's why we're a trade hub.
But it's also a vulnerability.
A massive one. It also means we have 7,500 kilometers of vulnerability to cyclones, to tsunamis, and increasingly to sea level rise.
Which brings us back full circle to that hook I threw out at the beginning about the sun rising early. The time dilemma. You mentioned the longitudinal extent is about 30 degrees.
Correct. From Gujarat in the far west to Arunachal Pradesh in the far east.
And the NCERT text says there's a time lag of 2 hours. But why 2 hours specifically? Can we break down the math for the listener who might not be an astronomer?
Yeah, it's simple math, really.
Yeah.
The Earth rotates 360 degrees in 24 hours. That's one full circle.
Okay.
So if you divide 360 by 24, you get 15. That means the Earth rotates 15 degrees every hour.
Okay, I'm with you. 15 degrees equals 1 hour of time.
So since India spans roughly 30 degrees of longitude, you just do 30 divided by 15, which equals 2.
Yeah.
2 hours of rotation.
So physically, the sun actually rises in Arunachal Pradesh 2 full hours before it rises in Gujarat.
It does. It's wild to think about. When a person in Arunachal is having their morning tea at 6:00 a.m., someone in Gujarat is technically still in the middle of their deep sleep cycle, solar-wise. To the sun, it feels like 4:00 a.m. there.
That's incredible.
And this creates a massive ongoing debate called the time zone dilemma. You know, in the Northeast, especially in the tea gardens of Assam, they often operate on something called chai bagan time.
Garden time.
Yeah, tea garden time. It's an informal time zone that's an hour ahead of the rest of India, just so they can maximize their use of daylight for work.
But officially, we don't do that. We don't have an East Coast and West Coast time, like the U.S., for instance.
No, we don't. And you can imagine why. If every town and city kept its own local time based on when the sun was highest, it would be chaos.
Absolute chaos. Trains would crash. Banking would be impossible.
The whole grid would collapse. We needed a standard. We needed one single time for the whole country.
And that's where the standard meridian comes in.
The standard meridian of India. It's fixed at 82 degrees, 30 minutes east.
Why that specific number? 82 degrees and 30 minutes. Why not just 80 or 85?
It's largely for convenience and symmetry. That line passes through Mirzapur in Uttar Pradesh, which is roughly in the center of the country, longitudinally speaking.
So we split the difference.
We split the difference. It might be an hour off for the folks in the Far East and an hour off for those in the Far West, but it unifies the entire nation under one clock.
One nation, one time. I guess for a developing nation, the administrative simplicity just outweighed the benefits of having multiple time zones.
That's exactly it. The coordination costs were just considered too high. But the text also mentions something else about latitude affecting the duration of day and night. This is different from longitude.
Yes, it says the difference between the duration of day and night is hardly felt at Kanyakumari, but is very, very distinct in Kashmir. What's going on there?
This is a concept that often confuses students. It's all about your distance from the equator. Kanyakumari is at 8 degrees 4 minutes north. It's very, very close to the equator.
And at the equator.
Day and night are almost always 12 hours each, all year round. The tilt of the Earth doesn't affect the equator much in terms of daylight hours.
Right.
But the further you go from the equator, north or south, the more the tilt of the Earth affects the length of your day.
So up in Kashmir.
Kashmir is way up at 37 degrees net. That's significantly north. So in summer, the days are very long, maybe 14 or 15 hours of daylight. But in winter, the nights are very long. The variation is high.
And down in Kanyakumari.
The variation is barely 45 minutes between the longest summer day and the shortest winter day.
So our geography dictates our daily rhythm. Quite literally. If you're a solar power planner, this matters. If you're an agriculturalist, this matters a lot.
It does. But let's zoom out again. We've looked at the grid, the size, the time. Now we need to get to this so what. This is where we enter segment 3, strategic geography.
This is where we connect the dots to those mains questions. The NCERT says India has a central location between East and West Asia. What does that really mean?
Central is the key word. Look at a map of the Indian Ocean. It's the third largest ocean in the world. And now look at India's position. We aren't just sitting next to it, we are hanging into it. The text calls it the southward extension of the Asian continent.
The Deccan Peninsula.
Exactly. The Deccan Peninsula protrudes deep into the Indian Ocean. This physical shape is India's single greatest strategic asset. It divides the ocean into two halves, the Arabian Sea on the west and the Bay of Bengal on the east.
And that protrusion is what allows us to reach out.
Precisely. Think of the peninsula as a giant pier or a dock extending into the sea. From our western coast, we have easy, direct access to West Asia, to Africa, and on to Europe. From our eastern coast, we connect directly to Southeast Asia and East Asia. We are the natural bridge.
The NCERT puts it beautifully, I think. No other country has a long coastline on the Indian Ocean as India has.
And that's the justification for the ocean being named after the country. It's a claim to what we call an eminent position. But let's connect this to a PYQ, because this isn't just trivia, this is policy.
Okay, hit me with the linkage. I know our listeners love the PYQ connections.
Okay, take a question from 2016 GS2 Q18. It asks about the economic and strategic dimensions of India's Look East policy.
Or the Act East policy, as it's now called.
Right. Now, you might think that's a pure international relations question, but the foundation of that policy is right here in Chapter 1 of Class 9 Geography. Why can we look east? Why is that a viable policy for us?
Because of our location.
Because our eastern coast and the Andaman and Nicobar Islands give us physical proximity and maritime routes to Southeast Asia, to the vital Malacca Strait. Our location is the policy driver. If India were landlocked, like Mongolia, an Act East policy would be a meaningless phrase.
That's a great connection. Geography enables policy. If we didn't have that coast, we wouldn't have the leverage.
Or take 2020 GS1Q14, which talks about the interlinking of rivers. Why do we even need to think about linking rivers?
Because of the size and the diverse climate we talked about.
Exactly. We have this massive landmass where the north floods during the monsoon, while parts of the south are in drought. Or look at 2025 GS1Q4, which asks about climate change and sea level rise impacting island nations.
That brings us right back to that 7,500-kilometer-long coastline.
Precisely. India's eminent position makes us a trade hub, absolutely, but it also makes us deeply vulnerable. A 1-meter rise in sea level would impact millions of Indians in coastal cities like Mumbai, Chennai, Kolkata. It's the double-edged sword of our geography. We profit from the sea, but we are also at its mercy.
Speaking of trade hubs and profits, there's a specific historical fact in the text I wanted to touch on. The Suez Canal.
Ah, yes. 1869, a pivotal year in global trade.
The text says, since the opening of the Suez Canal in 1869, India's distance from Europe has been reduced by 7,000 kilometers.
7,000 kilometers. That's just a massive number. Think about it. Before 1869, if you wanted to ship cotton from Mumbai to London, you had to sail all the way down and around the Cape of Good Hope in South Africa.
A long and dangerous journey.
Months. A logistical nightmare. You had to brave the perilous waters of the southern Atlantic.
And the Suez Canal cut right through Egypt, connecting the Red Sea to the Mediterranean.
And just like that, India is practically neighbors with Europe, economically speaking. This cemented India's role as the jewel in the crown of the British Empire, because resource extraction became so much faster and cheaper. Bombay, now Mumbai, exploded as a port city, specifically because of this canal. It all comes back to location.
It really does. It transformed us from a distant, faraway outpost to a central hub in the British global trade network. Now, let's shift our gaze from the blue of the ocean to the land. Let's talk about the neighborhood. Segment 4.
The neighborhood is complex. We have land neighbors and sea neighbors. And to be honest, it's a tough neighborhood.
Let's run through the land borders first, maybe clockwise from the northwest.
Sounds good. In the northwest, we share borders with Pakistan and, of course, Afghanistan.
Right. Although, for the sake of accuracy and clarity for our listeners, that Afghanistan border is technically the Wakhan corridor bordering the Pakistan-occupied Kashmir, or POK, region.
That's a crucial point. It's a border de jure, if not entirely de facto at this moment. Then, as we move north, we have our giant neighbor, China. Specifically, the Tibet Autonomous Region.
And tucked in between
Are the Himalayan buffer states of Nepal and Bhutan.
Buffer states. That's an important geopolitical term.
Yes, historically, Nepal and Bhutan served as buffers between the two Asian giants, India and China. Geography literally placed them there to keep the empires apart.
And then, as we swing to the east,
We have Myanmar and Bangladesh.
okay, here's a quick trivia question for the listeners listening at home and for you. Which states share international borders versus those that are completely landlocked? I think this helps visualize the internal map.
That's a really good exercise.
Yeah.
If you look at the map, you see states like Haryana, Madhya Pradesh, Chhattisgarh, Jharkhand, and now Telangana. They're the heartland states.
Right in the middle.
They don't touch the sea, and they don't touch a foreign country. They're landlocked within the nation. They're protected in a geographical sense.
Whereas a state like West Bengal is fascinating because it touches the sea in multiple countries, Bangladesh, Nepal, and Bhutan.
True. West Bengal is a geographical marvel in that sense. And this brings us to a historical linkage. We have to integrate the history sources here. The borders we see on the map today, they aren't natural lines. They're man-made and very recent.
Right. The text mentions that before 1947, there were two types of states in India, the provinces and the princely states.
Right. Provinces were directly ruled by the British. Princely states had local rulers who would acknowledge British suzerainty. Now, why does this matter for geography?
Because the partition lines were drawn through them.
Exactly. When partition happened in 1947, the borders weren't drawn on a blank slate. They were drawn through these existing administrative units and, more importantly, through deep-rooted cultural regions.
This connects directly to a PYQ from 2014, CSPQ 81, about the partition of Bengal in 1905.
Precisely. Lord Curzon tried to partition Bengal back in 1905. The excuse was administrative convenience, but really it was about dividing a massive, politically active region. That 1905 map, that logic, eventually ghost wrote the 1947 Radcliffe Line that created East Pakistan, which is now Bangladesh. You cannot understand the geography of our eastern border, why it zigzags through villages and rivers, without that history.
And speaking of borders and culture, there's another one, 2020 GS1Q10, which asks about regionalism and cultural assertiveness.
That's a beautiful connection. Geography creates regions. The geography of the flat Punjab plains is distinct from the hills of the Northeast. These geographical silos create distinct cultures.
And when you draw a political border through a unified cultural region,
Kind of like splitting Bengal or splitting Punjab between India and Pakistan, you get friction. You get regionalism. So the map tells the story of the culture, and the border tells the story of the conflict.
let's move south again, back to the water, our island neighbors.
We have two main ones, Sri Lanka and the Maldives.
Sri Lanka looks so close on a map, like it's almost touching India.
It is very close. It's separated by a very narrow channel of sea formed by the Palk Strait and the Gulf of Mannar.
Palk Strait, that's P-A-L-K.
Yes, and it's very shallow, which historically meant that big ships couldn't pass through it easily. They were forced to sail all the way around Sri Lanka.
And that still affects shipping lanes even today, doesn't it?
It does. The whole Sithu-Samudram shipping canal project was proposed to dredge this channel, which just shows how a simple geographical feature creates massive economic projects and debates.
And the Maldives?
They are further down, situated to the south of our own Lakshadweep Islands. They're a long chain of atolls.
Which is the perfect segue to segment 5, the islands, the archipelagos of India. We have two main groups, and geologically they couldn't be more different. Let's start with Lakshadweep.
Okay, Lakshadweep. These lie in the Arabian Sea, very close to the Malabar coast of Kerala.
The name itself means 100,000 islands in Sanskrit and Malayalam, doesn't it?
Ideally, yes. But physically, they're tiny. The text notes they cover a small area of just 32 square kilometers. That is incredibly small.
And the capital is Kavaratti?
Yes, Kavaratti is the administrative headquarters. But the most important geographical fact about Lakshadweep is its origin. These are coral islands.
Coral islands, meaning they were actually built by tiny marine organisms.
Exactly.
Yeah.
Coral polyps. They secrete calcium carbonate. They're skeletons, basically. Over thousands and thousands of years, these build up into reefs, and eventually they break the surface of the water and become islands.
So they're biogenic, made by life.
That's the perfect term. They're biogenic. That's why Lakshadweep is flat, sandy, and has that pristine blue water. It's an atoll formation.
Okay, now contrast that with the Andaman and Nicobar Islands way over in the Bay of Bengal.
A completely different beast. The Andamans are big, they're numerous, and they're scattered over a huge area. They form an elongated chain running from north to south.
And their origin story.
Tectonic. They are believed to be elevated portions of submarine mountains.
Submarine mountains. So these islands are basically the peaks of a huge mountain range that is mostly underwater.
Yes. In fact, many geologists believe they're a southward extension of the Yolma mountain range that runs through Myanmar. And because they're mountains, they're tectonic.
Yeah.
And because they're tectonic.
They can be volcanic.
Exactly. And the text gives us a crucial fact here. India's only active volcano is found on Barren Island in the Andaman and Nicobar group.
That's a key fact for prelims, Barren Island. It's the proof of the tectonic nature of that region. It's loosely part of the whole Pacific Ring of Fire system.
It is. And thinking of tectonic activity, we absolutely have to talk about the tsunami connection.
The 2004 Indian Ocean tsunami, it was a defining moment for our modern geography.
The text notes that the southernmost point of the Indian Union was Indira Point. Well, physically it's still there, but it got submerged into the seawater during the 2004 tsunami. The land actually sank due to the violent movement of the tectonic plates. It literally changed our map.
And this links directly to a PYQ from 2025, GS1 Q7, which asks, what are tsunamis, how and where are they formed?
It does. If you're answering that question in the mains, you don't just explain the physics of a tsunami. You have to cite the impact on India. You mentioned the vulnerability of the Andaman and Nicobar Islands. You mentioned the submergence of Indira Point. That shows the examiner you aren't just reciting a definition, you understand the application to India's geography.
You know, I want to bring up another QIQ here. This one's from 2014, GS1 Q18. Explain the formation of thousands of islands in the Indonesian and Philippines archipelagos.
Ah, that's a classic. Now, the chapter we're reading is about India, but the logic is exactly the same. The Andamans are part of the very same tectonic collision zone that created Indonesia and the Philippines.
So it's the meeting of the Indian Plate and the Eurasian-Burma Plate.
Right. So by understanding why the Andamans exist, submarine mountains, plate tectonics, you can directly answer the question about Indonesia. And conversely, Lakshadweep gives you the perfect model for coral island formation, which you can apply to the Maldives or parts of the Great Barrier Reef.
It's like having a mental toolkit. Once you understand the tool, be it plate tectonics or coral formation, you can apply it anywhere on the map.
That is the essence of geography. It's not about memorizing every single island. It's about understanding the process that makes the island.
Let's move to our final segment, physical features and geophysical phenomena. This is where we take all this location data and apply it to some of the advanced concepts.
Let's start with the big one, the Himalayan Wall. The NCERT Chapter 1 mentions that India is bounded by young fold mountains in the northwest, north, and northeast.
Young fold mountains, that's a very specific geological term.
It is. Young means they were formed very recently in geological time, just a few tens of millions of years ago, which is nothing compared to the ancient Ara valleys. Fold refers to the process. The Earth's crust literally folded up like a rug being pushed against a wall.
And this connects to 2014 GS1 Q17, which asks, why are the world's fold mountain systems located along the margins of continents?
Oh, that's a big conceptual question. But look at India. The Himalayas are on the northern margin of the Indian subcontinent. Why? Because that's where the collision is happening.
Between the Indian Plate and the Eurasian Plate.
Exactly. The text in Chapter 1 sets the stage for this entire collision story. You can't have the Himalayas in the middle of Madhya Pradesh. They have to be at the margin where the two plates meet and crumple.
So the location being at that collision point creates the relief feature, the mountains.
And that relief feature, the mountains, in turn creates the drainage.
The rivers.
Yes. Now you can link this to 2020, GS1 Q6, melting of Himalayan glaciers, or even 2025 GS1 Q17 about the distribution and density of population in the Ganga River Basin.
Okay, connect the dots for us. How do we get from Chapter 1 location all the way to population density?
Okay, it's a chain reaction. Step 1, location. The Indian Plate moves north and collides with Asia.
Right.
Step 2, relief. This collision creates the Himalayas. Step 3, drainage. The Himalayas hold massive glaciers, which melt and create perennial rivers like the Ganga and the Brahmaputra.
And those rivers bring water and silt.
Step 4, agriculture. These rivers bring down fertile alluvial soil and water to the plains, creating the Indo-Gangetic Plain. Step 5, population. People settle where there is abundant water and fertile soil.
So the massive population density of UP and Bihar, the fact that hundreds of millions of people live there, is basically a downstream effect of the tectonic location of India.
It is all connected. You cannot separate Chapter 1 location from Chapter 3 drainage or Chapter 6 population. Geography is a system, a chain reaction. If India were located 10 degrees further south, we wouldn't have the Himalayas, we wouldn't have the Ganga, and our entire population map would look completely different.
That is a brilliant way to visualize it. Let's talk about one more phenomenon, disasters. We mentioned tsunamis, but what about cyclones?
There's a question. 2014 GS1Q19. Tropical cyclones are largely confined to the South China Sea, Bay of Bengal, and Gulf of Mexico. Why?
And how does Chapter 1 help us answer that?
Remember what we said about our eminent position and the shape of the coastline. The Bay of Bengal is shaped like a funnel.
Right, it narrows at the top.
And it's tropical. It's south of the Tropic of Cancer. The warm temperature of the water and the enclosed, funnel-like shape of the bay make it a perfect breeding ground for powerful cyclones. If India didn't have that eastern coastline, or if the Deccan didn't protrude into the ocean creating that bay, our cyclone history would be completely different. The geography creates the hazard.
It's just fascinating how the static shape of the land determines the dynamic risk to the people living on it.
That's the so what of geography.
Yeah.
It's not just lines on a paper. It's about risk, resources, and ultimately survival.
We have covered a lot of ground and a lot of water today. It's so clear that Chapter 1 isn't just an introduction, it's the anchor for the entire subject. Let's head into the intro and try to recap this incredible journey.
We started with the grid, with 8 degrees 4 minutes north to 37 degrees 6 minutes north. We realized that while those numbers look static, they define our climate zones, our harvest cycles, our daily lives.
We solved the time travel mystery between Arunachal and Gujarat and established why Mirzapur dictates our clocks just to keep the trains running on time.
We then looked at our eminent position in the Indian Ocean, how that Deccan Peninsula acts as a bridge to the world, facilitating trade but also exposing us to all sorts of maritime threats.
We took a tour of the neighborhood, seeing how historical lines from 1947 and even 1905 still define our political reality today, creating both friction and connection.
And we dived deep into the islands, the coral atolls of the west and the volcanic peaks of the east, and connected them to major disaster themes like tsunamis and volcanoes.
And finally, we saw how the collision of tectonic plates creates the mountains that feed the rivers that support the people. It really is a complete interconnected system.
Geography is indeed the stage upon which history, economics, and international relations act out their dramas. You can change your economy, you can rewrite your laws, but you cannot move your country.
You cannot move your country. That's a powerful takeaway. But before we sign off, we did promise a final provocative thought, something to keep the listeners thinking about the future of this map.
Here's something to mull over. We talked a lot about how the Suez Canal in 1869 reduced the distance to Europe by 7,000 kilometers.
Right, it redefined global trade.
It defined the 19th and 20th centuries. It made our position central. But today, the Arctic ice caps are melting due to climate change, and new trade routes are opening up in the Northern Sea Route, right over the top of Russia.
Oh, wow. The so-called Polar Silk Road?
Exactly. If that Arctic route becomes viable for year-round shipping, a lot of trade might bypass the Suez Canal and the Indian Ocean entirely to move between China and Europe. It would simply be faster.
So the question is,
if the Suez Canal redefined India's centrality in 1869, how will the melting Arctic redefine India's central position in the 21st century? Is our strategic advantage permanent, or must it evolve? Are we ready for a world where the Indian Ocean isn't the only superhighway of trade?
that is a chilling pun intended and very powerful thought. The map is static, but the routes on it are dynamic. We could lose our eminent position if we don't adapt. Thank you so much for that analysis. That brings a whole new layer to what seems like a simple Class 9 textbook. Listeners, you have been listening to a deep dive into Class 9 Geography, Chapter 1. This was a presentation by Simplified UPSC, by PPP, and once again, a humble reminder from us. Please subscribe to the channel. It really helps us. And if you are capable, please consider supporting us on Patreon to keep this kind of content coming. A huge thanks again to our existing supporters. You guys are the best. And don't forget to like this video and share your valuable comments below. We actually want to know what you think about that Arctic question. Will the Northern Sea Route hurt India's economy? Let us know. And finally, don't miss out on the resources. Get your free notes and practice PYQs on the public Telegram channel. And if you want that premium experience, the organized private library with detailed notes, extra PYQs, and model mains answers, just DM us on the public channel to join. Keep looking at the map, keep asking questions, and keep learning. Until next time.
Goodbye and happy study.